Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Arif Fahmi bin Baharum, and as for today, I would like to explain to you guys about some knowledge that we've learned in fluid mechanics ECW422 subtopic 2.3, which is buoyancy. The objective of the study is we want to write and analyze the equation of buoyant force and some cases regarding the floating bodies using the principle of static equilibrium. Next, we want to define the condition of buoyancy, the stability of floating bodies, and the term of metacenter with the location. First thing first, we want to go to Archimedes' principle. So back to the history, Archimedes kept thinking why the water keep rise up when he got into the bathtub. So one day King Hirontu asked him to figure out whether the crown that he received made of pure gold or not. So what Archimedes do? He take a mass of gold and a mass of silver, which equal to the mass of crown, and he put into the water respectively. So he will know that the crown is legit or not based on the volume of water displaced. If the volume of water displaced by the crown is equal to the volume of water displaced by the gold, therefore the crown was original. Then pop up from his mind that the thing that he thought in the bathtub was soft. Archimedes stated when a body completely submerged or partially submerged in the fluid, there will be a force act vertically upward called as buoyant force. The formula of buoyant force can be defined as Fb equal to the density of fluid times the gravitational acceleration times the volume of water displaced, and can be written as buoyant force Fb equal to gamma times volume of water displaced, since gamma is equal to the density of fluids times the gravitational acceleration. Next, there are three types of condition of buoyancy. The first one is when Fb buoyant force is higher than the weight of the object. Therefore, the object will float and being called as positive buoyancy. Next one is when the buoyant force Fb is equal to the weight of the object. The object will suspended and being called as neutral buoyancy. The third one is when the buoyant force Fb is lower than the weight of the object. The object will sink and known as negative buoyancy. Do you ever think about a submarine? How can it sometimes rise up and sometimes sink into the ocean? So the submarine is using the concept of ballast tank. Well, when the air is filled in the ballast tank, the submarine will rise to the surface because it has a positive buoyancy, since the weight of the submarine is lower than the buoyant force Fb. With the water inside the tank, the submarine will have negative buoyancy. As the weight of the water will increase the weight of submarine, so it sinks deeper into the ocean. So next, before we go to the stability of the floating bodies, we must first understand the term of YCG, YCB, and YMC. YCG can be defined as the center of gravitational force, YCB can be defined as the center of buoyancy, and YMC is the metacentric height, which can be determined by the formula YCB plus MB. Let's go through this example so we can understand better the term and the relationship of the stability of floating bodies. See the example. The equation gave YCG is equal to 0.8 meter and we need to determine the stability of the flat boat. So first thing first, we need to draw a free body diagram. After that, using the equation of static equilibrium, the summation of Fb equal to 0. As we can see, we have Fb minus W equal to 0. Therefore, Fb is equal to W. Volume of water displaced is base times length times x, which x is the height of the submerged body, and we can simplify the Fb equation to get x. To get x, W divided by gamma BL, so we insert the information given, which Fb equal to 150 kN, gamma is 9.81 kN per meter cube, B is 2.4 meter, and L is 6 meter. So we can find the height of floating bodies, which x equal to 1.06 meter. Therefore, we can get YCB equal to x divided by 2, which is 1.06 meter divided by 2. So we get 0.53 for YCB. To determine MB, we'll calculate the second moment of inertia, which BH 6 times 2.4, which is the power of 3 divided by 12. Because it's rectangle, and to get MB, we divide the answer with the volume of water displaced and we get 0.5 meter. YMC is YCB plus MB. Therefore, 0.45 meter plus 0.53 meter equal to 0.98 meter. why CG can define point G, why CB can define point C, and why MC can define point M. So, the body will considered as stable if the point M is higher than point G and C. So, back to the equation, we can measure the Y from the base. So, point M is higher than point G, so the flat board is stable. But if the point M is between point G and C, the object will have overturning moment due to its instability. So that's all from me. I hope you enjoyed this video. May be easy, stay safe, stay at home. Assalamualaikum.